Okay, we are back to this thing. So, I would like to remind you that you should go ahead and follow this channel so that you will get all ongelama videos lengwafakago recently. In that way, you don't have to come in and check. It will just send you a message that there's a new video that has been uploaded. And then, yeah, that will help you as well as help me. It helps me in a way that I will know that there are people who are interested in these kind of videos. So I keep on posting them. And then it helps you in improving your maths. So we continue with some examples on calculus. So now, this channel has been made for mostly matric students in South Africa. So, but it can help anybody else anywhere in the world. So, don't mind me when I say like this is coming from an exam in South Africa, because basically most of the problems that I solve over here are coming there. So I'm trying to help those people, but I don't mean to say that it can't help you. Okay, this is another problem that I found in the matric exam in South Africa. So there are two ways that I will ask you calculus problems. The one is when they ask you to solve a derivative, and there are two other ways that they will ask you to solve a derivative, and I think I've already introduced you to that. And then the other one is when they tell you to find solve a problem using first principles. That one you have to use the limit theorem in order to solve it. Okay, now I have a problem here which says find the gradient of the slope using the limit and derivative method. Oh, I wrote derive over there. Excuse me. Okay, this is math, it doesn't matter over there. F of x equals to x squared. And we have to solve this at x equals to 6. Okay, so what do? The first thing that we should be doing over here, we use is where there is an x on the equation, we put a 6. So the equation itself, I don't know why I didn't write it down over here, but if I use a different color pen, I'll show you the equation. Okay, let's write it here below. So it says the limit as h approaches 0 of f of x plus h, okay, minus f of x divided by h. Okay, so in this problem over here, what we did, we say, okay, where there is x, we're going to put 6. On this equation over here, where there is x, we're going to put 6. So we end up having like f of 6 plus h minus f of 6 divided by h. Okay. Now on the next one, this one, 6 plus h squared, why did I get rid? You get rid of the f over here. And then you're going to square it because your f of x over here is squared. That is why we're having the square over here. Now on this one, we get rid of the f. And we're still going to square it over here. We'll square the 6 over there. I don't know if you understood that. And then we leave the h as it is. And then after that, we're going to devolve. That's an English word. It's like, okay, 6 plus h squared is the same as 6 plus h times 6 plus h, right? Okay, the 6 squared, it's 36 divided by h. Okay, when you do your math over here, when you say 6 times 6, it will give you 36. It gives you 36. And then h times 6, it will give you 6. But, okay, wait, so let's backtrack. 6 times 6, it gives you 36. 6 times h, it gives you 6h. Then h times 6 over here, it gives you 6h. And then the previous 6h, you add it to this one. Then it gives you 12h. And then you have like h times h is equals to h squared. This 36 over here is the one that's coming over there. So we took it down over here. But then now we're trying to solve the whole thing. So we are canceling what cancels. 36 minus 36 is 0. So get rid of that. We're left with 12h plus h squared divided by h. Okay. Mind you, while we're doing this, we're trying to get rid of this h over here. But it's hard to get rid of that h over here by just taking the limit, because taking the limit, it means like you just take the 0 over here and put it for h everywhere here. If you do that, mathematically, you will be dividing by 0, and you can't do that. You can try it with your calculator over there and put in like any number, and then you say divide by 0 and see what comes up. I'm sure that it will be yelling at you like, what are you doing? You know, I don't do such a thing. Okay. To prove it, to prove what I'm just trying to tell you over here, I have my calculator here. So I am going to do just that so that you will see what I mean. So on mine, if I turn it on, I say, for instance, 8 divided by 0. Let's see what it says. That's an error. Okay. 8 divided by 0. Let's say 56 divided by 0. What is it going to say? It's still going to say the same thing. You can't do that. I didn't want to have 2 divides, so I only needed 1. Okay, still giving me the same thing. So that was proving to you that you have to get rid of that h over there by not putting the 0 just yet, up until it solves itself. Okay, let's continue. We'll see what I mean. Okay, now when you get to this stage over here, this h is dividing this h squared as well as dividing this 12h. So you can, what you usually do, you take this h and divide it to that, and then take this and divide it to that with the plus sign in the middle. So 12h divided by h plus h squared divided by h. In that way now, you're going to cancel the h's on 12. But on this one over here, this h is only going to cancel one of the h's that are here, because these ones are 2 h's. It's h times h. So one h is going to go down, and then you'll be left with 1h. And then now when you get to this point, limit, well, you can read it like that. Limit as h approaches 0 equals to 12 plus h. Now you take the limit. When you take the limit, you take the 0 and put it for h over there. And then 12 plus 0 is 12. So our answer comes down to 12. Okay. This problem, I also did it with the derivative method. Okay. Why did I do that? It's because sometimes you will be there in an exam. Actually, this one over here, they give you the formula that I wrote here. It's already there. So always try to practice as much with this, because they will ask you a question saying that use f of x, solve f prime of x using first principles, and they're expecting you to be using this equation. Nothing less than this equation will give you the answer. Like, they don't want you to use the derivative. So that should sink in right now. So if you practice this, it's not hard, it's easy. So it just needs you to practice it. The problem that they have, the problems that they have for this equation are 5 points. So you don't want to lose 5 points, because if you use the other derivative that I'm about to show you, they probably will give you 2 or 1 out of 5. So you don't want to lose points unnecessarily. Okay, now here I'm showing you to solve this very same problem. So f of x equals to x squared, and then we're solving it at x equals to 6. So f prime of x, we're going to use this logarithm. No, not a logarithm. It's not a logarithm. We're going to use this equation. So what does that equation say? It says like, whatever is your exponent over here on x, take that exponent and minus 1, and then you leave it on that x, and then take that exponent again and put it in front over here. So now when we do that, because I didn't do it over here, I see that okay, let's say f prime of x equals to, okay, our f of x was x squared right there. So what we're going to do, we're going to take, we say n equals to 2. So this one is telling us that the n should be here. This is the n, and then we have the x over here, and then we're going to have our n minus 1. Okay, now what is that equals to? Okay, 2 would stay here, it's fine. X is fine, and then 2 minus 1 is 1. So the answer here would over 2x to the power 1, which is the same as 2x, because anything to the power 1 is that thing. Okay, now going ahead, because we are going to solve it at x equals to 6, so that is why I wrote f prime of 6 equals to 2x. So what you do, you take that 6 and you put it in the instead of the x. Where the x is supposed to be, you put the 6 over there. Then you do the math. 2 times 6 equals to 12. That is the same answer as we got over here using the limit theorem. So, but again, be careful. When you write your exams, if they ask you to use first principles, use the limit theorem, use the equation they already gave you over there. But if they did not, everything is fair, so you can use the derivative to solve it. I know the derivative it's easy, but when you look at the limit, yeah, it's challenging. It's not like it's hard. It's just a little much. Okay.